Hello, this is Mrs. Moslick, Geometry, Chapter 8, Trigonometry. We are starting with Notes 8.1 on the geometric mean. Right now I want you in pencil to work on the warm-up. As you're working on it, please pause these notes. When you are done with the warm-up, please unpause the video, get your red pen, and make corrections. So pause the video. Okay, you should be done with the warm-up, and the answer is 97. The reason for that is you are averaging those 5 numbers. Averaging 5 numbers means you're going to add the 5 numbers and divide by 5. In this problem, you are going to cross multiply, solve for x. An arithmetic mean means the average of numbers, where you're adding the numbers and dividing by the number of items. Notes 8.1 is on the geometric. A geometric mean is like the arithmetic mean. They are finding the average set of numbers. However, in a geometric mean, we use this more in finance and in geometry. There are a lot of examples and applications in geometry for the geometric mean. One of them is squaring a rectangle. For instance, if you have dimensions 4 by 9, the area is 36. If you want to square that rectangle, meaning you want the same area of 36, the dimensions would be 6 by 6. Another application of the geometric mean is using a right triangle. When you have an hypotenuse, the altitude to the hypotenuse, we'll call that h, that altitude is the geometric mean of the two pieces of the hypotenuse. So h is the geometric mean of x and y. We will do an example like this at the end of notes. Here's a reason why h is the geometric mean of x and y, and you don't have to write this down. This is using similar triangles. We are going to use similar triangles, proving the Pythagorean theorem in our next set of notes. Geometric mean also relates to the ratio definition. And algebraically, a geometric mean, you multiply the numbers and then take the nth root of the number of items. So, for instance, finding the geometric mean of the 3 numbers 4, 6, and 9, you multiply the 3 numbers together. And because there are 3 numbers, you're going to take the cube root. To take a cube root of a number, you still want to find the prime factorization of those numbers, put them in order, and then you are going to group them. So you have the cube root of 2, 2, 2, 3, 3, and 3. Because it's a cube root, you're going to circle 3 of the same number. So out comes a 2 and a 3, and your final answer is 6. Let's do another example. We want to find the geometric mean of 5 and 45. So to find a geometric mean of numbers, you multiply them, and then you take the nth root. In this case, we have 2 numbers, so we're going to take the square root. Find the prime factorization of these numbers. Oopsies, that would be 5 and 9. And then put them in order from small to big. So we have the square root of 3 times 3 times 5 times 5. Because it is a square root, we are going to circle pairs of the same number. So out comes a 3 and a 5. So our final answer is 15. So summary, if I want to find the geometric mean of 2 numbers, multiply them and take the square root. Another example is example 2. I want to find z, x, and y. Let's find z first. Z is the altitude to the hypotenuse of this right triangle. Therefore, since z is the altitude to the hypotenuse, z is the geometric mean of those two pieces, 8 and 25. So we are going to take the geometric mean of 8 and 25. So that means we are multiplying those two numbers and taking the square root. Normally, we would find the prime factorization. However, in this problem, it asks us to round to the nearest hundredth. So we're going to use our calculator and approximate to the nearest hundredth. So in your calculator, put in square root of 200, and we get about 14.14. So that is our answer for z, which is an approximation. We are now going to use that answer to find x and y. Let's now go ahead and find x. Now let's look at this red right triangle. Note that the red triangle is a right triangle. X is the hypotenuse, and therefore we are going to replace the C with X. The two legs of the triangle are Z and 18. So we're going to use 14.14, which is an approximation. So we're changing that equal sign to now an approximately equal sign. So we're not going to have a exact answer. For our class, it is acceptable to use the approximate answer from Z. If you were taking an AP calculus class, you have to use the exact answer for that Z value, so you would use the square root of 200. But for our purposes, just use that approximate answer for Z. In your calculator, put in 14.14 squared plus 8 squared, and then take the square root of that answer, and we get about, again, rounded to the nearest hundredth, we get about 16.25, and that is our answer for X. So 16.25. Now to find Y, we're going to look at another triangle. Let's look at this green triangle, and that is a right triangle with the hypotenuse being Y. So again, we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. This case, C is our Y value. We are going to use the approximate answer for Z, which is 14.14. So our equal sign changes to an approximate equal sign, and our other leg of the triangle is 25. So in our calculator, 14.14 squared plus 25 squared, then take the square root of that. We get about 28.72, and that is our approximate answer for Y.